students. We'll be continuing with the operating system concepts. The first unit, operating system overview, will be continued in this session. Myself, Dr. Shirisha, Associate Professor from CSC Department, MLR Institute of Technology. As we have discussed a few things, we'll discuss what is the introduction to operating system. Then we'll just continue with the topics. So the definition what we have seen is it is acting as an intermediary between the user and the hardware. So that's what we have seen. So here also program that acts as an intermediary between the user, a computer and a computer hardware. That means user and the computer hardware. So what is its purpose? So the purpose of an OS is to provide an environment where user can execute conveniently and efficiently. So you should manage the time within the shorter period of time. You should complete your process execution, and you should use different resources timely manner, so that the resource will not be idle and it should be allocated with some or the other process always. So that is a efficient and convenient manner that we have to use all the resources in the operating system. Then is a software that manages the computer hardware, not only the processor, along with the different resources that we are going to connect. And hardware must provide appropriate mechanism to correct operation. So we have to, with the help of user perspective and also the kernel perspective, we have to change the bit modes so that your operations can be performed correctly. Okay. So to prevent the user programs for interfering with proper operation of the system. Suppose if you are doing any process intermediately or in between, if it is struck or it has been stopped executing, then it will be a problem. So such things has to be taken care. Then operating system goals: execute a user programs and make solving user problems easier. Make the computer system convenient to use and use the computer hardware in the efficient manner. So operating system it is a mediator between a user and the computer hardware, where the kernel is supporting in all the cases. So operating system structure. So operating system is divided into 4 components. What are the hardware components? You need to know what is operating system, how it is going to control, and how the hardwares are being used, what are the different applications that are being installed in the operating system, and how many users are going to use the OS. And the application programs, so there are system programs and application programs. So there are 2 types, system programs and application programs. Okay, so system programs are nothing but like whatever the ROM and RAM we use, there will be some sort of code that is already been setting up while you boot your system. So such data which is already recited in your system, so such things we can just call it as a system programs. And when your OS is built, then you will be having something like calculators and basic browsers, and say Notepad will be the common editor. So whatever you are getting by default, these are all can also be said as system programs. Coming to application programs like Acrobat Reader and MS Office, and whatever the softwares that are being downloaded and installed by the user, so those all can be said as application programs. Next, so it defines the ways in which system resources are used to solve the computing problems of the users, say word process, compilers, web browsers, database systems, video games, etc. And users, who are the users? Users here may be a people, maybe the machines or the other computers. Machines here are the other computers. So this is about how the OS will be. And there are 4 different components. So starting from the hardware to the user, we have been divided into 4 components. Okay. So first you should have hardware. Until and unless you have hardware, your OS cannot be installed. If you have OS, then only you can work with the system or application programs. And if you have these application programs, who are going to use them? The users are going to use them. So this is a bottom-up approach where you should have initially the hardware for using all the users to use either the compiler or the assembler or the text editor or database system or anything that is been installed, either it is a system application or a software application, user applications. You have to maintain the hardware and the OS first. Okay, this is a basic question that will be asked for the long answer type question. What are the different components of the operating system along with the operating system structures? Then operating system perspective. There are two ways where you can see the operating system. One is the user view and the second is the system view, where system view we also call it as a kernel view. Okay, operating system view from the user view, the main goal is to maximize the work. Okay, the more processor is executing the more number of processes, that is nothing but maximizing the work. OS is designed mostly for ease of use, so you have to use it very easily. Some attention paid to performance and non-paid to resource utilization. So how you can manage a process management can be considered as a user view. And resource utilization, how your hardware and software resources are being shared. Suppose if you have a printer that is connected to two different processors, then at a time if two different processors are giving a printing at the same time, then it will be a issue. So that has to be managed. So utilization should be managed. That we're calling it as a resource utilization. And the other thing is a system view, where I told you there's a kernel view. OS is a resource allocator also. OS is a process controller also. OS is a device controller also. So OS, the other definition is operating system is a resource allocator. What are the resources that are available? How to manage them? How and when they have to be allocated to the process? That will be taken care by the operating system. The OS, that is about the resource allocator. OS has many resources that may be required to solve problem, that is CPU time, memory space, file storage, IO devices. So all these are nothing but what we have discussed in the previous session: process management, memory management, device management, file management, etc. So now OS is a control program also. It controls all the programs. Suppose if you are using, there is some sort of priority. If you wanted to give any priority for any process, then OS should be capable of stopping that current process, and it has to give a chance for the prioritized process to get its execution. So control program, it manages execution of user programs to prevent errors and improper use of the computer. This is about the operating system in terms of either the kernel or the user mode. So this is a dual mode operation that can be performed. As I told you, there are two different modes. In order to ensure the proper execution, there is a difference, or there is distinction between the execution of OS code and the user code is given. So if it is a user mode, then that bit is given as 1. If it is a kernel mode, then the bit it has to be converted to 0. So when we will be converting into two different separate modes? Suppose if you have given a process for the execution, then the user bit will be converted to kernel mode. Now kernel has to execute the process. Suppose there is some intervention, there is some interrupt here, then this process cannot execute, and this mode will again go to the this mode where it converts again to the 1 bit. So 1 bit means again you are telling the user to give another process for execution as this current process has been interrupted. So that in that way you are utilizing the processor very efficiently. And computer system is run by user application, a text document, or using an application program. The system will be in the user mode. Whatever the user is using, then it will be in the user mode. And supervisor mode or system mode or privileged mode, that we are calling it as a kernel mode. It's a bit of the computer called the mode bit. It is used to indicate the current mode. If it is 0, we are calling it as, we understand that it is in the kernel mode. If it is 1, we understand that it is in the user mode. So with the mode bit, we are able to perform a task that can be executed by the OS and that can be executed by the user. If it is a user mode, user will perform. If it is a kernel mode, then OS can perform the task. So, in such a way, the performance is increased and it makes more efficient. Okay. Next. So, this is a diagram with one example. When the computer is executing user application and the system is in the user mode. So, here a user process, it is executing some process. To execute that process, it calls the system call, and whenever you have called the system call from this user mode, it is changed to the kernel mode. Now, the kernel has to execute that system call. So, what is the bit here? Mode bit is 0 because the user mode is executed. User mode has given kernel to execute. So, kernel mode bit is 0. Now, again, whenever this mode bit is execution of the system call is completed, then it has to again return to the user mode. So, whenever it is converting to the user mode, this mode bit 1 is being changed to 1. 0 is changed to 1 because kernel mode to user mode it has to move. Similarly, vice versa. Whenever you wanted to move it from the kernel mode to user mode, it is converting 0 to 1. And whenever you wanted to convert from user mode to kernel mode, then it is converting 1 to 0. Here there is a trap. A trap is nothing but it is a software generated interrupt. Whenever there is an interrupt, again it will return from the system call back to the operating system, user process or the user mode. Okay, very, very important. Then, so based on this user mode and kernel mode, you could manage process management, memory management, file management, whatever we have discussed so far in the previous session. For the process management and the memory management, we can go through the previous session. And here there is a protection and security. So, how to definition of the security? Security here in terms of operating system, it revolves around the external environment. It also requires an appropriate protection system. Okay, so protection is where you are protecting the data by not giving the access to any other, like access privileges or permissions, access control list, we call all these. Security is where you are providing encryption, cryptanalysis, performing the cryptanalysis, or performing something like firewalls, gateways, so that the third or unauthorized person cannot access the current data. So, this is the difference you have between the protection and the security. One of the long answer type question which is asked is the difference between the protection and security and its explanation. So, the security systems including the protecting of computer resources against unauthorized access, malicious alternation, inconsistency. Okay, so this is about security, and we will see what is the protection. Protection is apart from the security, it controls the access. So, as I told you, we can call them as a ACL, access control list. Okay, to defining the types of file access allowed. Okay, what are the files that can be allowed and executed? Protection of system must ensure the authorization of the process or the user. Authorization is also very important. If someone is giving the permission, then only you can access those files and perform the execution. So, this is about the protection and security. And this is the differentiation between the comparison chart or the differences between the protection and security. So, how basically what is the definition? So, it provides a system access and it control to legitimate users only and controls access to the system resources. And it handles more complex concerns and quite simple concerns. Policy describes which person is allowed to use a system and here it specifies what files can be accessed by a particular user. Type of threat, there will be external threats in terms of security like virus, worms, okay, bugs and all. External protection is required for providing the security. Internally, by giving the access control or permissions, we can just control this and threats can be custom or reduced. And mechanism that is used to provide security is authentication, where we are doing today by performing one-time OTPs or one-time passwords like OTPs, or you can perform username passwords like that. And also encryption is also performed where your plain text is converted to ciphertext, and this is again a different subject. And set or alter authorization information, like if you know, like we'll have, suppose if you have internet, okay, if you wanted to publish this internet previously, the history of internet, when you wanted to publish this, there will be some board, IAB, Internet Architecture Board. So this is what it is authorizing, how the documentation of this internet has been written, where it is going to take the RFC commands from the users who is going to use the documentation. If these commands are positive in terms of the documentation, if it is positive, and it will be having a 6 months of time based upon these RFC. RFC is nothing but request for comments. The users who are using them will be giving the comments, and those comments, if they are positive, then it is released into the market. So why I am taking this example is there is something called IAB, Internet Architecture Board, where it is authorizing to perform different, to give different document, I mean whatever the documentations has been released by the authors, so it is open to all the users so that they can freely give their comments. Okay, based on that, IETF, there is IERF, so something like different organizations are there to release internet, so that today we are readily using the internet and the networks. Okay, and finally we'll be seeing about the distributed system. And in the first part, we have different operating systems, and what is process management, what is memory management, and what is a file management, device management, and protection and security. And this is the last topic in the first part of your first unit, which is a distributed system, how the data is going to be distributed. If you see this diagram, you have a centralized computer system where all these computer systems, you have node 1, node 2, node 3, node 4. All these 4 are connected to your centralized computer system, and these are being maintained by this centralized computer system. It coordinates activities and shared resources, either the databases or anything, using a distributed system software, so that whatever the modifications that are being done here, so could be easily maintained or easily known to the centralized system, so that accordingly whatever the changes that are possible, that can be done easily within less time. Okay, therefore increases the performance. So distributed system is a collection of autonomous computer systems that are physically separated but are not connected to centralized computer network, that is equipped with the distributed software. Okay, it's a collection of computer systems, okay, that are connected to the centralized systems. And autonomous computers will communicate among, autonomous means these are all under the autonomy of the centralized computer. That's why it is named as, I mean, it is called as autonomous computers, and will be communicate among each system by sharing the resources, files, and perform the tasks. So this is resource sharing, or the database data is being shared. That is about the distributed system. What are the different characteristics? So it is open to all, so that the central data can be shared to everyone. That is the openness. And resource sharing is possible, so either it may be a data, hardware, or software. Concurrency, where it deals with the same activity or functionality that can be performed separate users. So it has been shared, because since it is shared, each individual will receive it and they can use in different scenarios. There is a concurrency. Scalability, the increase of scale of number of processes or number of users that the data can be shared. So scaling, number of computers that are being connected to centralized system, that can also be increased based upon the cost and based upon the requirement. Okay, so fault tolerance, whenever there is some system which is failed, you should be capable of managing such data from the previous nodes. The best example for this will be the big data, where the cluster of systems are connected to the central system, where you'll have a master nodes, and also, I mean, master slave architecture will be there. Name nodes will be acting as a master, and the slaves are nothing but the data nodes. So that is one of the best example that you can take for the centralized systems. So where you'll have 3 duplicates of data. If one system data is failed, you'll have the same data in the other system. So so that the data is not lost. And transparency, it hides the complexity of distributed system to the users so that it is always available. The data is always available centrally, can be shared anytime, can be used by those systems anytime. So in that way, it is very transparent. Okay. So it is not that centralized system is having the data and no one should use it. So it is shareable. So we will be using inter-process communication like message passing and shared memory with respect to this distributed system to share the data. And what are the advantages of distributed system? You have, along with the advantages, you also have some disadvantages. We'll see them. Advantages, applications are inherently distributed. Yes, anything can be distributed. Information is shared among geographically, that means remotely, not only in the same place, but it is not inter-communication. Inter-process communication is also possible in the distributed system. Resource sharing is possible. Any type of resource that is capable of sharing, then it could be shared. Better price performance ratio and flexibility, shorter response time and higher throughput. Shorter response time because it is shared to everyone. So you will have someone or the other, some system or the other will respond very quickly. So the response time is very shorter, so that it increases the throughput. Throughput is number of times the time taken by a program, by the process to execute its task. That's the throughput. How many number of process you are executing in a given stipulated time. So that is also a throughput. So it has higher reliability and availabilities because this is centrally shared. The data is always available. Reliable is in all the environments. Whenever there is a failure, SPOC central system is being failed, then also it is reliable of executing the process because you have the cluster of nodes, other nodes. So what are the disadvantages? Relevant software does not exist currently. That's one of the disadvantage. Security poses a problem due to easy access. So because it is being shared, there might be few security issues that can be prone where privacy attacks or passive or active attacks can be possible. And networking saturation may cause hurdle in the data transfer and the lag in the network. So network issues, because the same network, if you are using among different systems, then obviously you will be getting a network issue. It will become slow and all. For the best example, when you get the results, all are using the same page, but same server page is used by number of users, then the server page might become slower. That's one example for this. So apart from the advantages, you also have these disadvantages. Hope you all understood. Thank you all.